Usually when I'm working on random 8-bit computer hobby projects and things like that, I don't really blog or vlog about it until the end, and then I might write a really lengthy blog article or occasional video about that. But I thought it might be kind of fun, just for my own records and for anyone's interest, to sort of document one of these projects that I'm kind of getting into as I go along, the learning experience and possibly development output of some new game or application for a system that hasn't really been much with community or discussions for decades now. So we'll see how it goes. This first one will just be sort of an overview and talking about this unique little TV out adapter that supports some interesting hardware. So let's just see how this goes. It's completely unscripted. I have a very simple setup here with sort of I guess it would be like a selfie stick tripod mounted with a phone running Droid Cam OBS, with which acts as a webcam for the physical hardware here. Then above that we have the video out, which currently is not connected to anything, but that runs through just a cheap $20 HDMI capture card, and actually runs through a composite to HDMI converter, since this obviously only supports composite or RF. And then that will give us a nice display on the screen to show you as I work with the video out aspect, which is my main interest in this. And then on the right side here, we have just a simple OneNote documentation where I might take notes as I go along to eventually build my own website or sort of portal to HHC references. Because, like I said, other than a couple websites floating around with some overview introduction information, some resources, a few documents, there just is not a lot out there about this system. It was released in 1981 from Panasonic. It also went by Quasar as a different name, and later was marketed by General Electrics for programming radios. So it was sold as a briefcase computer with some custom hardware. And honestly, it's a pretty versatile little system here. It was obviously built at the time when others, like the TRS Pocket computer, which I need to repair in another project, but and Casio had some. So there were just all these companies coming out with, at the time, pretty revolutionary computer in your pocket sort of systems. And this would allow anyone to um, go wherever and take notes, document things. Reporters started using some of these for actual kind of on scene reporting and journalism. And with Panasonic, they really caught on with insurance agencies. And so you'll find in a lot of these, they have custom ROMs that were made for different agencies to for agents to go to client houses and take down all this information for accounting and insurance and things like that. And they could record it all on here and then go back and transfer it via maybe a RS-32 interface or some other means. But they would have all of the information here to then later input into an actual system. And on the back of these, as I was saying, it actually supports three different capsules, and each one is a ROM chip. And so you can actually have three different programs running at once, or more if you have what they called an external ROM pack, which also supported, I think, four per ROM pack. So you could have 7 different applications able to select at one time. Now, this is the Microsoft Basic, which is the main one I will be referring to. And you can see it actually is just a normal ROM or EEPROM, and it just has the legs bent over around a small little plastic carrier, which made it, I guess, convenient and kind of proprietary, where you could freely lug them around. They used to have little carrying cases with them too, and then you could just easily swap them in or out without worrying about broken legs and other things common with normal socketed chips. And the other two in here are custom, as I was saying, a little hard to pull out. Um, was custom insurance agency things. This one is dated June 1985, and it's called PTOV I don't know what it's called, but it's there's a couple applications and data files, and these are just things I've picked up over the years. But the Microsoft Basic one is of most interest because that's one way that we can actually tap into the programming and hopefully get some interesting output. Now, when they released this device, they kind of came up with their own variant on Fourth, which was a more efficient and optimized, probably more structured programming language back then, but also far more complicated for end users and home users to pick up and learn compared to Basic. So they developed a Snap Basic cartridge, or capsule as they call it, and a Snap Fourth. And both of these were just, you could plug them in just like the Basic here and code in their own sort of specific language that could then much more easily interface with all the different features and components here, the IOs, different accessories and things. Whereas Microsoft Basic is a much more kind of trimmed down programming experience where to actually access any of these things, including the video out, we have to do a lot of poking and peeking and escape characters, control characters, and things that are a lot more cumbersome and not well, if at all, documented. And so that's going to be part of the experience here, is to sort of take notes and document things and see what we can come up with. Now, it's just a basic LCD thing, but it does have a 6502 CPU built in, which was very popular in the time. It came in configurations of, let's see, 2, 4, or 8 kilobytes. And this is actually the 8KB model. So if I go to the IO section, you can see internal RAM, and it's got about 7KB free. You could buy RAM pack accessories, and each one of those I think had 16 to 32 KB in them, or even more potentially, using bank switching and things like that. But yeah, so this is what it is, and it by default includes a calculator, a built-in clock, and alarm clock, which actually does have a little chime, and you'll probably hear it because I have it set up to play randomly. I think every, I don't know how many minutes it plays, until I would go in there and cancel it. A file system where you can create new files and type basically text documents, and then it allows you to load Snap programs if you have. And that's a long, complicated process, but that would be like using the Snap Basic or Snap Fourth. You could actually load those programs into RAM and then load them into here, copy them from one device to another. And then after the fourth one here, that's where we get into the capsules on the back. So right now I've got Microsoft Basic, another personal finance custom. Again, a lot of these were accountant or insurance related things. So if we go into Basic here, this is just a variant of Microsoft 6502 Basic. So it's pretty common. I mean, as far as that was a popular variant for almost every system back then. And we'll just create a new file, and I'm just going to call it test. And I should mention, so the keyboard here, it's a little weird to type on, just those little calculator keys. We have standard keys, then you've got a shift key, and you can see as I press it, you get a little triangle to show which states or which keys are pressed or not, which is useful. The insert will allow you to add text without overriding it and things like that. So you've got uppercase, lowercase, uppercase, and then you got a second shift key, which is used to do parentheses and custom things like that. You've got some kind of macro buttons down here. The only one that I found that works in Basic is C1, which will just break out of any program like here. The arrow keys to navigate back and forth. Rotate, I'm not sure that works in Basic, but if we go back to the main menu here, rotate will actually... Okay, if you load in a program that has text and stuff, rotate actually then scrolls it like a marquee scrolling thing. Now, when I exited Basic, there's a slight glitch in it, or a bug, or maybe it's by design, I'm not sure, but if you exit without saving, you can see it wrote a B file to the file system, and that actually fills up the space, so we actually have to go in there and delete it before we can do much more, because you can see now only 2 bytes left. So I'll select that, I'll hit delete, and then I'll press enter. You're supposed to exit Basic by typing the word bye. So with that said, though, let me just kind of show off this video output again, because it's a very sort of obscure extension thing here. In fact, you won't find any videos or really hardly any discussion. There, you just heard the chime. That was the little beep noises. So that gives me hope that that might be programmable too. Not documented, but maybe we can get in there and it would be cool to be able to experiment with the onboard sound too. Anyways, yeah, there's not much information about this adapter at all. And in fact, it's not supported by default in Microsoft Basic either. It would be, I think, in Snap Basic and Snap Forth. But like I said, this Microsoft Basic, which is the only capsule I have, I do not have the other two programming environments right now. So I'm just going to use a lot of poking and kind of some undocumented features, I think, of Microsoft Basic to try and tap into some of these hardware things as I go along. It'll be interesting to see what happens. But this video out, the closest, it wasn't even written much in publications, but I did find this article in a newspaper or magazine, I should say, that actually talks about it. This was when it was branded as a Quasar, but it's got a little the old style of modems, analog. There's a term for them, and now I'm spacing on the name, but they're the kind that you actually plug in the headset of the phone into this into that actual original modem, and then the tones from the phone actually is what transfers it. So very old um, way of doing things, but it supported it. And there's a little tiny miniature monitor there, and that might be a simulated display, but it shows that yeah, you can output color and text and everything like that, versus just this small. I guess it's a 8 by 159 dot pixel um, dot matrix LCD display there. So that's what I'm intrigued by, and you won't find any hardware specs about this thing online. You know, you'll find some of the resolution stuff which was published, but I opened it up, and it actually inside has a Motorola 6847. So that was actually a pretty popular chip back in the 1980s for video graphics on some of these uh, lower range or first run systems. The original Color Computer used it. The Tandy MC10 used it. The Imagination Machine used it. Some of these systems and still very capable for graphics, and that's why I'm intrigued to see if it might be possible to develop a new game or application for something that really just hasn't had any kind of discussions or conversations about for a long time online. And that's kind of what I'm interested in, these obscure systems. Like I got into the Mattel Aquarius a couple years ago and developed a new tool set that's being used by the small community now for designing artwork and prototyping applications and stuff with a online tool that I made for that ancient 1983 system. So I'm just kind of I'm intrigued by these sort of systems like this. This also has, along with the internal character ROM, that's I believe part of the graphic chips itself, or possibly a separate one. Yeah, I'm pretty sure it's built into that graphic chip, but it also has a second character generator that could be customizable. By default, it supports. Oh, there's dialects. I don't know if it's a Japan-based language or something. There's certain glyphs on there for another language, and then it also has the Bloxel style semi-graphic characters that you can actually create certain things with. So it's kind of exciting to me. So what I'm gonna do here now, let me turn this off here for a moment, and then I'm gonna just plug this in. So like I said, it just simply plugs into the side here, and now you have an extended module with the video out. And I am going to run, I just have, it doesn't support audio out, but I've got just a simple composite cable here, and I am going to plug that into the video out. It also supports RF. So originally I was actually trying to feed this through a VCR into just a much older capture card, but it had just didn't look good for capture reasons on video here, and this works pretty well. So I've plugged it in. I plugged in the composite. That's going into the capture card. Now, if I press on again, you can see it's got the list of things, and then if I press the IO button, now you can see we've got in slot 0 the video out. Now if I had that expansion interface, which I do, but it's not hooked up right now because it's not necessary, you could plug in like RAM packs, you could plug in even ROM packs, printers, uh, other interfaces, modems and stuff, and all of those would show up on this IO, and they all have their own, well, not all of them, but most of them, I'm pretty sure, if not all of them, they do have their own ROM packs, and so each one has its own sort of operating system or functionality built in within the hardware itself. So if we go here and we see the video out is off, if I just come here and press 1, now you can see, oh, I thought that should have worked here. Press 1. Okay, that's weird. That's not working now. Let me... Weird. So you can see I'm not... Okay, maybe it's because you can see I exited, it says I only have 26 free. So I'm gonna go back into the file menu here. And let me just see, let me just press 3. So there's a test. Yeah, only 26. I'm thinking the video out itself might require more RAM than what. So now that's cleared. Let's go back here and go to IO, press 1. There we go. There we go. So now you see I enabled video, and now above that you can see exactly what the output by default looks on this thing. Now this is the first time you've seen, I tell you, there's not much out about this TV adapter online. So this is kind of an interesting exploration here. Now, if I go back to any of these, like if I open calculator now, as you type here, it mirrors it on the screen. Let's see. And you get the nice multi-rows instead of just everything on one. So definitely has a use, but it's just not been discussed or found or used much in the wild. So that's what I'm intrigued by, to kind of see what the characters are available to us and the colors, and see if we can find a way to tap into this from Microsoft Basic to then potentially create a simple game, something, maybe Snake, the Apple Muncher style game I've developed on some other platforms in the past that became popular. Panasonic Smart TV, I developed oh man, that must have been 10 years ago or so. I developed a Apple Muncher is what it's called, and it was one of a couple indie games ever released on that market, and it's been played millions of times now, and there's still a really active community of these smart TV users playing that exclusive game on that. So anyways, it'll be new to me as I go along here, but you can see that the video out is working successfully. And now if we go back to, let's go into Microsoft Basic. And again, and I think I mentioned this already, but if not, the downside is Microsoft Basic is a very kind of stripped down version. It's pretty much the same Microsoft 6502 that is available on many other platforms from then. And Microsoft did open source that itself, so that's intriguing, and people are, I think, doing some interesting things and porting it to other platforms now. But the problem is it does not support like native functions for much with the HHC at all. There's a couple commands that are unique to this that in time we'll look at, but most it's basically vanilla, and so you can see it doesn't even support, as you type here, it does not support video out, at least by default, and there's no like command that just directly allows you to do that. But there is an attach command that allows you to do interesting things with certain it's kind of like an IRQ type thing where you have you can just attach interfaces without really knowing anything about them, but then to communicate mostly you have to do escape characters, and it just it's Snap Basic would be the better one to use for this, but this will be just kind of interesting. So with that, I don't really know what to do this session. much. But I wanted to at least try and see if we can at least tap into the interface here and just see if we can get some output on the screen there. And to do that, thankfully, this version of Basic does support poke and peek, and you can basically peek into any memory address within it and write, or at least try to write, to any. So basically, this TV interface here has its own ROM built in and might be utilizing some of the RAM, basically to show that display up there. And so, what is the memory map? Well, again, there's not too much out there about it, but I did find, and now I'm just trying to. You can tell I'm absolutely not prepared for. This is a very unscripted sort of, oops, experiment here. But I did find a few hints in Byte magazine from 1981 when it had a feature story about the HHC, and it as part of that, it talked about. Let me just see if I can pull that up here. Yeah, so in this HHC story, it mentions here that the 8K byte address area from memory locations 2000 to 3FFF hex is used by the specialized firmware that is contained in each HHC peripheral. When a given peripheral is being used, the firmware that controls its communication with the HHC is selected and used. This area also contains the memory mapped contents of the video display when the HHC is connected to the color TV interface. So that's a good first step of where to start poking and prodding around to find where this is. And I also did read that the memory map or the video capabilities of this output is a double page system, so you can actually have 2 pages of text depending on the graphic mode and things like that. But yeah, so I guess this actually is a good kind of foundational point. It talks about bank switching and the different memory allocations based on what bytes of RAM you have and how much RAM and stuff. So it was the most informative article. There were not many articles written about HHC, but this was 13 pages of information that delved into quite a bit about it. But again, I haven't just started exploring this. So with that, let me just open up. I might make a new tab here, and I'm just going to call it Memory Map. And this will be, I'll just take some notes here randomly. Let's just see, hex, decimal, description. And now, so we know that hex 2000 to 3FFF is, I will say, 8K address area for peripheral ROMs, and includes video memory mapping when AV adapter is plugged in. Okay. And decimal, I'm just going to cheat and open a calculator and open programmer calculator here. And so 2000 in hex starts at 8192, and it goes to 3FFF, which is 16. So it's the 8K to 16K kind of map area where that goes to. So that gives us a lot of room to poke. And again, I do have some more documentation and information about this that I'm just starting to explore, but just as a start here, I think we can kind of whip up a 3 or 4 line program here that will basically iterate through all of those chunks of memory and see what happens on the screen as we go along. So let me just so you've got your print commands, and a shortcut in most of these basics, you can do a question mark. So if I do let's see, where well, let me just, if I do a print FRE and then 0 or whatever, I think any number in there, this will tell us how much free memory we have, and that's just something to keep. Okay, so we're at about 7 KB. Um, I'm trying to think here. So you can also do question marks to print things, and we're not. Let me just see if anything changes here. So I'm just going to start, and I'll just do. Let's see, 10 for I equals. Let's see. I equals, and we'll just start. We'll go 8192 2 1 6 3 8 3. And that'll just iterate through every single possible address used by this video adapter there, as the extension there. Um, and then let's see, so 20 will be, we're just going to simply poke. I can't remember if I'm supposed to use parentheses here or not for this. I don't think so. I think I'll just, let's try poking. We'll poke that memory address. So we'll poke from 8192 to 16383. And we'll just poke the value 65 into there, which I know is the ASCII A character usually. So that'll be fine. And then we'll just do next I. I like that little X in that. It's an interesting character there. Um, okay, so I'll just run it and we'll see if we have any. Now, it's not going to show anything on the screen here, but we might see at some point along here what if it finds something in there, then we'll know that the memory is accessible through BASIC in this way. Um, and other things might happen, other weird things. So with that uh, display or with that graphic, what am I trying to say? Oh, look at that. So there we are. We're filling up with a red background, yellow text A. Interesting. So, okay. So we can output to the screen from BASIC using poke. That's one thing. Um, so now to narrow that down, let me just see here. So you can type list to get back to the code. So I'm gonna go through that all again, and I'm gonna I'll just change that to 60. Actually, let me go back. Let me go. I think there's 60. Well, let me just see what poke. Instead of 65, let me poke the value 1 to this. And then I'm actually going to I'll add a line 25 and I'll say, what am I going to say? Actually, you know what? Let me add a 15 and I'll say, n equals n plus. I'm just trying to, oops, that didn't work. I'm trying to think if it would be nice to output this, but I know printing every single. You know what? Better idea. Uh, I am gonna go. I'll go 25, and I'll print I, which will actually give us sort of an indicator here of where we're at in the loop. But I don't want to call it every because let's just see how. I feel like that's gonna be very slow. Very slow. We do not want that. Printing is a very slow command in BASIC, so we try to avoid that as much as possible. Um, but what I will do is I'll go back to line 10, and I'm just going to say, I'll add a step value. So I'll say step 100. So now this will go up by 100 every time, but we still should see something change on the screen, and then we can kind of narrow it down from there. So now if I run it, you can see 8192, 8292, 8392. So this will go a lot quicker, not quite as fast as I thought yet, but we'll see when it starts kicking on there. Um, boy, this is too slow yet. Well, we know it's not anywhere before 10,000 now. So I'm going to break out of there again. And I'll just do a list. And let me go back here now. There, you might have heard that in the background. That was a little alarm going off. Let me change this to 10,000 to 16,000. And instead of step 100, let me say step, no, let me just go step 500 for now. Oops. And let's run it now. So I got 10,000, 10,500, 11,000, 11,500, 12,000. We'll see. 13,000, 13,500, 14,000, 14,500, 15,000, 15,500, 16,000. Huh. It did not poke anything. Interesting. Let me poke 66 instead. Try it again. Oh, so at 12,000 and 13,000, we did get something going. And at 14,550. Okay. So it was like at so now I'm just gonna go. You don't have to run a program to. So I'm just gonna so let me just experiment here. So poke 12,400, comma 67. That changed. You can see in the second row it added a I think we're in for some reason this is the character set that is, I think those are glyphs that are showing up, but so okay, so we're almost to the, so let me poke, what was that? So let me go 12,300, or is that what let me do a 64. Okay, that's interesting. A green A, poke 12,200, let me 12,250, 68. Okay, so something, so again, so poke 12,300. Let me just try 80. Uh, what I think is happening here, and I've seen this in some other languages, some with their memory map, they have like 1 KB of pure color data, and then like after all of that, then it's 1 KB of text data. I think this one might be doing something a little weirder. Poke 12,400, 65, because we know that's, but I want to try 66, and that is at 12,400. Okay, so that changed the color of that to green. Poke 12,401. Now we're back to red A. Poke 12,402. Now we're a green symbol. So I think this might be cycling graphic modes. 1 byte of graphic data, then the next byte would be the actual character. So let me just go up one more time. Poke 12,400, comma 3. Oh, see, now we're red background. Okay. Poke 12,401. Now let me do a 67, which should be like a C. And it's not. It's okay, but that changed that same spot. So there's 2 bytes per text character, I'm noticing. So now if I go back, poke 12,400 and set it back to 1. Oops, did I type that wrong? Poke 12,400. Oops, comma 1. Ah, so now we've got that C. And that's, does my mouse work on? Yeah, so I guess, yeah, I guess my mouse might not be showing up on there. But so, yeah, so the first byte is representing what character bank we're using, it looks like. So with that, so that's 12, and I'm just gonna come over here. Um, and I'm just gonna take a few notes as I go along. So and this will be revised, but so that this is a character, but it's not the initial one, but it's one that we know is doing something. So 12400. Let me just poke 12400 comma 0, and now I get that default green with yellow text. So okay, so um, green back BG, yellow foreground, and then a lot of that would be like the ink color and the paper color. Ink yellow, paper green, and then one gave us that red BG, yellow FG, and then 12400 comma 2 changes. So 2 is also green BG, yellow FG, glyph character. Okay, so uh interesting. What I want to do is I want to get back. So if each, and then so then you got 12401 equals actual character index for the spot in memory location 12400. So each character that we're seeing on the screen here is occupying 2 bytes. It seems like 2 bytes. I didn't try, let me try poke 12402, and let me give that a, let's see, let me give that a 0, which, let's see. Yep, okay. So that changed the next character tile over to, it set that to the mode 0, which gives us a green background and a yellow foreground. Now we supposedly can get 8 different characters and several different resolutions. In fact, the manual, which, oh, I thought I had it on hand here somewhere. It actually talked briefly about the resolution. In fact, 1 second here. I'm not going to edit this video or anything, so I was trying to, uh, just trying to find things, but apparently I'm not organized. Um, huh. Oh, here I found it. So here's the actual TV adapter manual. Just a few pages here, but somewhere in here it has specifications. Here we go, and it says number of characters. 32 characters by 16 lines, total of 512 characters. That looks like what we're seeing on the screen right now. So it's 32 by 16 in a index of, or a character block of 5 by 7 dots of character data in 8 by 12 chunks there. So that's interesting. We've got uppercase letters, lowercase numbers, um, numbers or lowercase letters, numericals, symbols. Total 116 characters. Um, Scrolling, when display exceeds 16 lines, each line moved up a line. Here, semi-graphics mode. Not much information in this pack at all, but it says semi-graphic. The capsule program provides this mode, semi-graphics 4 mode, one character box, 8 by 12 dot, divided into 4 elements, 4 by 6. Okay, so this would be the Bloxel character type data that I was talking about. Number of elements, 64 graphic elements by 32 lines, 8 green, yellow, blue, red, light yellow, buff, dark blue, cyan, magenta, and orange. Production of 2 or more colors at the same time is not possible for one character block. And that's extraordinarily common on most systems that I've explored, especially like Aquarius and I think Spectrum and the VIC Commodores and all that. They had similar limitations, so that's not too much of a hindrance. Semi-graphic 6 mode, one character box 8 by 12 dot divided into 6 elements, 4 by 4 dots. So this you can have 64 graphic elements at 48 lines. Again, um, yeah, I think that's just a separate style of bloxels that in their character set. Um, that's really it in this as far as the specs. So, but what I was saying is, yeah, so it looks like so if we take so that's at 12,400 the color mode for that, and that's, let's see, each line is 32, so that'd be 64, 63, 62, 61, 60, 59, 58, 57. So the 57th character mode is at 14 or at 12,400 equals 57th character from top left down mode. And then 12401 is actual character data for 57th for 57th, I'll say, tile. So with that, we should be able to so 12,400, and if each one is 2 bytes, so that's 57. 57 times 2, that's 100 and, oops. What? I times 2. Yeah, so 114 should get us back to that top tile there. So let me poke. Uh, Let me just do 12,290, comma 3. Okay, so that's the second character over. Poke 12,288, comma 0. There it is. We just found the mode setting at, what was that, 12,288? That would be our first graphic tile on the screen. 12,288 equals tile number 1 in, I don't know what mode I'm calling this, so I'll just say in 32 by 16 text mode. Now it seems so it's interesting because in a lot of systems, I guess it depends, but based on this, if we're sticking to the tile-based system, we can handle bloxels and different things per tile, so you can mix and match in any possible way. I'm not sure how colors play into any of this, but so there we go. So if I do a, let's just see, if I do a poke 12,289, and let's just do, so 65 would be character A, B. So if I do 66, that should put a B in that first tile there. Yep. So there we go. Cool. We got somewhere. I don't know how much more I want to proceed at this point, but that's good to know. So we've got 12. So now I'm just going to do a, I don't know if I need to do a new, I wonder if I can do, so let me just start at line 100 here and say for I equals, and now let's go 12,288. Actually, you know what? Let's not do that. Let's do for I equals 0 to 255. And what I'm gonna try and iterate and just be able to check the modes on that one tile here. So 110 poke I, comma, or actually no, poke 12,288, comma I, and this will start with 0 and then go and we should be able to see what that does to that tile there, and then we'll do the same. We can do the same with the next once we have that figured out. 1115 or 11 1 1 Takes a while to get used to this keyboard, I'll be honest. 115 print I. So this will tell us what the mode is doing and delay it a little bit, which is helpful here. Then 120 poke. Oh, we already let me just do a list 110 and just verify. Okay, so we already poke that and then we print it. So then we'll just do 120 next I. Done. And now we'll run it and let's just see, pay attention to that top left corner here, which right now is a letter B, and that should not change. But what will change is if the graphic mode switches to a different character set. That's when we'll see it change. So let's just see what this does. And I'm recording this, so I will be able to take more notes off log here of what each one is doing here. Okay, so you know what? I want to run. I'm not sure if I can do this, but normally in basic you can go run 100 and it'll start from that. It should work, hopefully. Yep, 0, 1 changes red, 2 changes to a different character set, green, red, green, red. Okay, and now look at that in the top corner. We are now seeing, and a blinking pattern. Green blink, red blink, invert blinks, and now we're back to, looks like it's, okay, so it's cycling through, it looks like it might be repeating here. So there's probably only a few. Yeah, so at 24 it started the blinking. And then we get 28, it starts the bloxel mode again. Let's just see again. So it looks like this is cycling through those different modes and different semi-graphic modes and different things. So some will support, so now it's blinking at 41. So 24, 34, 44, about 16 different variations before we get back to the, so green, so 48, let's just do that. So the green B was at 48. Let's just see. And now we're flashing again. This is interesting. Okay, and then 64, yep. So based on that pattern, every 24, so in like what, 88, when it gets to 88, we should be back to that solid green again. So that means there's 24 different repeating graphic modes here. Or 80, okay, 80, yep. 48, 58, 68, 64, 64, 74, 84. And 96. Yeah, so okay. Yeah, so that my math was off, but yeah, so every 16 it's repeating. So there's actually only 24 modes going through this. So that's helpful. And it looks like, so mode 0 to 1, standard text, green or red BG. Then so it's definitely just repeating here. So let me break out of that again. And let me just run it one more time here and just note, so oops. Come on. Run 100. So it's green, red, glyph green, glyph red. Glyph. And then it gets into the graphic color modes, which is interesting. So glyph, glyph. Then bloxel 1. And I noticed, so that first, So it'd actually be 0, 1, 2, 3, 4 through 6. I'd call them semi-graphics modes. And so that first graphic mode, that one right there, um, that you could tell was like the half split. So looking back on um, what they're talking about here, that would be one character divided into 4 elements. Yeah, so yep, that would be it. So the first one we see there, which would be mode 4, would be where we've got like one of 4 blocks filled in, so we can create a resolution, slightly lower resolution. The next mode would it splits it into 6 like individual sort of pseudo graphics that you can design stuff with. That's exactly like Aquarius. Actually, it has the same sort of built-in things. So then we get to 7 to 8, which are blink modes, which is also not uncommon for old systems with this video processor in there. So we got 4, 5, 6, 7 flashing green, 8 flashing red, then 9 and 10 are flashing glyph modes. And I'll at some point make this into a nicer documented system here. But but then what comes after? So this is like 5, 6, 7, 8. Okay. Well, with that knowledge, so now that actually is very helpful. So now if I do another list 100, so that we'll keep that, but now instead of poking that, we're gonna poke 8, 9 with the letter I, and that will run through the actual character sets. So we'll see here now how this goes here. I gotta stop doing that. Run 100. Okay, so it's a. Oh, and now the mode. I gotta stop that. Let's go back to the default mode. So poke 12 288 comma 0 to set it back to the green static mode. And now we will run 100, and this will now show us what character sets are part of what I would call mode 0 and mode 1. Run it. Okay, so the first character was an at, and now it looks like all uppercase A through Z it's going to be. So that would be character code 0 through 26, I'm guessing. Which actually matches the basic character internal ROM that is part of that graphics chip, as I recall. All capital, and now I think, is it going to be inverted here? No. Then we've got symbols. So 30, 31, 32 is a space. That's normal. We're still on symbols and characters here. 40, parenthesis. This is pretty standard ASCII style character set so far. So it's actually 27 through, it's going to be probably 64, 65, or at least maybe we'll see. At some point, this is going to do something different here. We're at 60, 61, 62, 63, 64, 60. Okay, so 64 is another at. and now it's repeating it again. So interesting. So it doesn't have lowercase. I actually had read that this chip, a modernized or an advanced version of it, actually had lowercase built into the character set here. So it looks like we got 0 to 26 are the base characters, and then you got 27 to uh it would be 27 to 63 uh basic symbols and such. And then 64, it starts repeating again. That also means when we get to 128, now let's just see what that does. This is a very crude method to figure this out, but it's kind of fun. And as I discover, and discovering different things here. So now we know the modes, and then the bytes next to that are for the actual values here. Um, so curious if after it gets to 127, if it'll then jump. Okay, ooh, inverted mode. So starting with 128, inverted mode. So now, yeah, so that actually changed the background to green and the text to black. Interesting. So that should be it. And that'll just repeat the same. So you get a few symbols, some arrows and spaces and stuff. But with that inversion, okay, so now that's just kind of curious. Okay, so I'm gonna break out of there because we know the character sets now, and that I assume would be the same for mode 7 and 8, which are the blink modes. Let's try mode 2 though. So I'm gonna poke 12 to 8. Uh, 12 to 8. I'll poke so the mode, and I will set that to. Let's try 2. So instantly that changed to a different character. So now if I start running at 100, this should now be the secondary character set, which somewhere I read is customizable. So it is, so there's special characters and symbols for different languages and stuff coming in here now. Then some usual ones too. It's kind of hard to see. I should have done red and yellow. That looks somehow much better on this. And there's those certain symbols I was mentioning before. Um, okay, so we are at 32 still maps to space. I'm just wondering if there's any drawable. So we could draw with these characters, but this is not the actual semi-graphics. Those must um those require that byte to be modes 4 to 6 to get to those special characters. So that's um okay. This is probably extraordinarily boring for anyone actually watching, but I'm gonna use this as a reference to um better plan out what to do next here. But this is still intriguing. So now it's gonna probably loop around here, 62, 63, and or not. Maybe this is a more full. Yeah, this could be a full 128 custom characters, all different from 0 to 127 instead of before when it was partially replicating because there's no lowercase. That reminds me of the original TRS-80 Model 1 that I spent many months restoring and custom character sets and all that stuff. That was the TRS-80 Model 1 originally shipped without enough uh, RAM character RAM or it didn't allow that final bit to be set. So even though the character ROM generator had lowercase in it, it did not support it on screen unless you did a hardware modification basically to add one piggybacked RAM bank onto there to support that final bit. So that was interesting history that was curious, but yeah, things were much different back then. So okay, so this is uh, just a interesting character set, and now the other thing I want to do now. So let's poke 12288. Interesting that that is the same memory bank where the screen dump is in Aquarius, I'm pretty sure, and probably a lot of other systems back then. So let's go to mode 2, which should be, or no, mode 4, which should be that bigger graphics mode. So there you can see that. Um, and now I'm just going to run 100 again. So it's nothing other than yeah, so you can see now it's filling up that box with all of the possible 2 by 2 character styles. And is it going to switch colors now when it gets to a certain point? Yes, it is. Okay, so this is where we're getting our colors from. Um, so it's just drawing. So this is mode 4. And so it's cycling through all 8 colors there, I think. Um, dark, yeah, okay. So there's blue. Yeah, okay. So that means that if I break out of there and do let's see. Let's do 5. Now there's a semi. I don't know the 5 and 6. That's a little curious, but let's do 5. 2. Okay, so that's actually still showing the 2 by 2 grid. Let's poke 12288, comma 6. Okay, look at that. Now we've got a more granular sort of character bloxels. And now if I run 100, I assume this will do the same thing, except now we'll get a 2 by 3 division, which gives us a lot more sort of drawing potential there than before. Now, I don't know if it's supported in this or not. I guess we will find out as I go along here in the weeks and months to come, probably, depending on if I have much time. Um, I feel like there is a way to do like specific pixel drawing, but obviously that's not a memory efficient way back then. So most routines and stuff they draw in this Bloxel style format. So that's, I think we know. So character mode 5, I, I feel like that might have just been, I don't know, maybe that deserves more attention later on. But so character is in mode 6 is 2 by 3 Bloxel style or system with 8 colors, and I think there's 8 colors being generated. So with all of this in mind, let's just do one final. I'm gonna. Oh, I just started the whole thing over. That's okay, but now I'm gonna have to. Let me go in there and Um, delete that phantom file here, and I may as well delete that test file. Okay. So let's put it all together here and just. I like the block. So what I can do here, I'll just call it I don't know, S dump, screen dump type thing. So we will go, and now that we know that at least one page, and I'm assuming this is going to be replicated at the later, like in bytes 14,000 and above too. I think we saw that earlier on, but we know now definitively that 12288 is the start of tile number one mode setting, and that's for any of these things. So any of the modes, that is the starting point on the screen for that. And then 12281 is tile number one character. Um, the actual character. So you set each tile first with the mode and then with the character. So that means you can mix and match it. So we could have text in certain rows and areas, and 2x2s in others, and 2x3s in others, and glyphs in others, and kind of do it that way. So the caveat, obviously, is that we only have green or red background and text if we're actually using the character glyphs. So, but that's not a terrible issue here, and we can always draw out our own characters as needed with this. So, with that, let's just do a. Uh, so I will start with let's see. So we're gonna need two loops here. One will go from 0 to 255. I'm guessing that'll be a lot of repeats for the Bloxel characters, but that's okay. So we'll go for, let's just do for C. This will stand for character. So for C equals 0 to 255, and then we're gonna do, that should be fine. Yeah. So then all we're gonna do is we'll just do a 20. We'll do poke. We're gonna poke every. Let's just see. So we want to set every. Um, we want to set every. So starting with 12288 plus plus C. I should have. That's okay. 12288 plus C. We want each one to be. Um. Let's let's just do graphics mode 6, and that'll give us that 2x3 um, character set type thing there. So we will poke that into, starting with the top left corner. We'll do that, and then I'm just trying to decide how I want to approach this. Because then we want 12281 will actually be the character code itself, but that would be plus. This is gonna, something's not right here. I think I need to do a step by two. Um, okay, let's just do it a little simpler here. How to? I'm actually gonna. I'll do. I'll just go back. So I'll go for I equals 12288 2. So let's calculate. Now we should be able to calculate. So if it's 32 characters by 16, 512, okay, and then times that by 2 is 1020. So 1 KB squeezes in 2 bytes per character there. So 1024. So 12288 plus 124 and 1024, 13312. Um let me just test this here. So poke 13312 comma 65. Nothing. Okay. Poke 13310 comma 6. There we go. 13310 would be our final row, and then poke 13, 3, 11, 5. Yep. Okay. 13, 3, 10. So with that, we know that 12, 2, 8, 8, 2, 13, 2, 10 equals 512 characters on screen mode. And then likewise, we got 12, 2, 8, 9 to that equals, and that's the actual characters, and that's every other one. So going back to here, let's just, what we can do here, we will iterate through every, so we'll go for I equals 12, 2, 8, 8 to um, 13, 2, 10, step 2, and then 20, we're just going to poke in there mode 6, 30 next I. This is just all for experimenting, because then when we run it, it should flag each one of those on-screen characters to set to mode 6, and then that should stay set, so then we can just generate the output. So let's run it. There we go. Look at that. Not quite to the end. What did I do wrong? 13, 2, 10. 12, 2, 8, 8 to 13, 2, 10. Oh, 13, 3, 10. That would do it. I think it's too late. I think it's too late to keep doing this. 13, 3. Okay. So that's okay. 3, 10. And now, there we go. And yeah, we updated that one character in that final one. That's why it doesn't show up. Just out of curiosity, if we poke 5 instead, that would be the 2 by 2, which I think is the same as 4. Yeah, okay. So let's go back, poke 6, get that done. And now all I'm gonna do here is just let's see. So now I'm just gonna change that to 8, 9 to 13, 3, 11. Step 2 is fine. And then see, that was 10. So let's do okay, so that'll go through. We are going to poke I with J at line 20. And on line 25, we'll just go J equals J plus 1. And we could even add a, yeah, that should be okay. I wonder if it'll error out though once it gets to 20 poke. Oh no. Thought I changed that. 20 poke I comma J. And then I will just do, I'll just add a 26 if J is greater than 255, then J equals 0. And this should just iterate through the entire color bank of Bloxos. let's just see how it goes. Look at that. It's beautiful. 4 colors. So we got 4 colors. Um, green, yellow, blue, and red. Okay. Um, well, it's something. So I'm just looking at the chart here again. Green, yellow, blue, red, light yellow, dark blue, magenta, and orange. Okay. Well, we're getting there. We have colors. We've figured out some of the memory mapping, the bloxels, the guess quite a few things here now. Um, I think I'll just take a screenshot of this and paste it in there for my own figurings later on. It's interesting that that is only so it repeats. So you got enough characters to draw whatever you want, but you've got only 4 colors. But I wonder if that's because we're in. Now I overwrote the other thing, but well, now that I got the characters all set, let me. This actually might be better. So let me go. Let me revert this back, and I'll just print. Okay, so let me just, or I'll poke. So that was mode 6. Let me go back. Let me do mode poke 5 now. This should update the mode, but keep all of the characters showing. Clearly, I did not do something right. um, that did not go right. I think because 228 122. Oh, yeah. I poked the wrong offset. I think I'll just do this. Poke I minus. No, let me poke 5. Okay. Oh, there we go. Well, we got okay. So we've got there's the other um some other colors. We got the magenta and the grays, and so that would probably be. And look at that. So yeah. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So mode 5, we do get 8 colors here. Mode 6, mode 5, and now 4. Okay, mode 4 is identical. So mode 4 and mode 5 are identical. So you don't get as high as resolution as mode 6. You in mode 4 you have 2 by 2 blocks basically to create sort of semi-pixel graphics. But you're limited to 4 or no, I'm sorry. Yeah, so mode 4 and mode 5, which are identical, it seems. One is a reserved number, maybe there's some other use for it, but you have 2 by 2 graphics, and you can use 8 colors. Whereas mode 6 gives you that higher resolution 2 by 3s for a more effective resolution canvas there, but you're limited to 4 colors. And while I'm at it, I may as well just finish this up. List 20. Poke. Let's do mode 3 now. And there we can see in full view the full secondary character set. Oh, and there is lowercase. So we do have lowercase in that secondary. Yeah, interesting. Okay. And it's red and green, red and so that was mode 3, mode 2. Mode 2 should be the same, just green, but I'll take a screenshot of that anyways. I'm not sure. I got to read up on I do have the basic manual and I got to look up if there's a recall command. That would be helpful sometimes. Yep, so now it does the same thing, it just changes it to green. Take a screenshot of that. And there is that final character 255. Oh, I guess it repeats, but that little kind of a cross stitch pattern, I have used that in other platforms for like borders and other elements like that. Alt code 1, what is it? 119, I think, or 219. I used to have all those memorized. Yeah. Well, there's alt codes for that on PC, and there's like 3 different shades and stuff like that. But, um, okay, so let me mode 2, and then mode 1 and mode 0 will be our base character set. Then we should be good for at least this session, and optimistic about where this might lead once I figure out better ways of actually poking in machine language data and making this faster to render and seeing how we can handle it in some basic routines here. So poke that. So this is the basic character set that I think is actually built into that video chip. So it's all uppercase, and then you get some special characters. Um, that'll be it though. So that will be that's mode 1, and then mode 0. We'll just do that real quick. And there's our green. Now I have it sort of documented. Um, so we went from not even having a display to kind of tracking down the memory bank using very old-fashioned way of just that's what people did back in the 80s to find and discover new things. They would just poke memory addresses as best as they could. I think I mentioned it and maybe I didn't, but the one cool thing about Microsoft Basic, even though it is so limited, you can't even interface with like the external RAM. You have to save it to the file system and then transfer it that way. If you have external RAM abilities or cassette interface, it's very convoluted. But it does offer. It's not documented anywhere, but it has that user and call commands. And I probably already mentioned this. It's been a long session here. Um, but those by calling either one of these, we can actually call machine language. So in theory, I could create some 6502 machine language that would draw a screen or populate things and call that from basic, and it would be instant. It would you see how the frequency, this is only a 1 megahertz CPU, so you see how fast things update or not, even on the screen here. But if we use machine language, it would be instant. The entire screen would load instantly. So that's ideally the way I would go forward, is to figure out a way to interface with a lot of this in machine language and see how we can do the same thing I did basically here, but then do it in 6502 assembly language and poke in those bytes and see what happens there. But for now, I mean, this was a lot longer than I thought it would be, and it was just me mindlessly brainstorming and exploring and discovering. But I think we made good progress, and I know that we can now output color and various character sets and glyphs using this ancient 1981 Panasonic HHC with the video out. That again, there's no reference. This is the first YouTube video ever made that demonstrates anything showing video out of this device. It's that rare. So it would be fun just to program something with it, make a game, make something new that has not, there, as far as I'm aware, there has never been a game developed for this at all, like none, because it was basically a business type system. But we've got beep codes, we've got output, we've got a decent CPU and a decent video generator and ROM character sets, even actually more versatile than the Aquarius that I've developed things on. So we'll see when my next session might be on this, but it was kind of a fun discovery, and I don't know, maybe someone will watch it and learn something or not. Either way, it's good for the record. All right, see you later.